So the only part that we have not yet talked about is the r-squared value. And that's what we're going to do here, is talk about what exactly does that mean. We know that r measures the strength, but what does r-squared mean? So the r-squared value, and yes, r-squared is because we're taking r, which we already know all about, and we're squaring it to get r-squared. Notice that that would always be positive because whenever we square something, the value is going to be positive. And it is called the coefficient of determination. And it's found again by taking the correlation coefficient, which is just r, and squaring it. So it makes sense that if r is between -1 and +1, that when I square it, my value will be between 0% and 100% because we always write it as a percent. And the what we talk about with the r-squared value is that it gives the percentage of variability, and remember variability just means change, the percentage of change that is accounted for by the model, or the percentage of change that's accounted for by changes in x. The 1 minus r-squared, or whatever's left over out of 100%, gives the percentage of variability that is accounted for in the residuals, in anything else that might affect the value. Residuals are errors. We want it to be low, but obviously, we can only do whatever the data gives us. So essentially, it gives us the strength of our model. The closer to 100% r-squared is, obviously the more useful it is, but don't ever expect to get an r-squared value of 100%. So as an example for us to understand what this means, we have the variation of the residuals for our fast food chain. Remember, we had our fat hat equals whatever our equation was, and our r value was 0.76. And so all I did was I computed r-squared by squaring 0.76 to get 0.58. And remember, I'm not going to think of it as 0.58, I'm going to think about it as 58%. So that tells us that 58% of the changes in fat content, so variability just means changes, 58% of the variability in the fat content, which was the X in fast food items, backwards. 58% of the changes in Y, which is our fat content, in fast food items is accounted for by changes in X, the protein content, because Y is, of course, the response variable. It's changing based on whatever X changes. Now, what does that mean? It means 42%, or very close to half, of the variability in fat content is accounted for by the residuals, which means what else could affect the fat content? Maybe how we prepare the food. Am I going to throw it in a vat of oil, or am I going to bake it in the oven, etc.? So one for you to try, if I told you the r-squared value for pressure and maximum wind speed of a hurricane is 0.773, interpret what that means. So again, in order for me to do this correctly, I would have to think about which one is X and which one is Y, and then talk about what that 0.773 means. So in this case, that means that 77.3% of the variability in maximum wind speed, because wind speed would change based on pressure, of hurricanes is accounted for by the variation in pressure, and that everything left over is left to the residuals. So other factors, and again, this part is not necessary, but it is important to kind of think about what other factors might be. So other factors like temperature, location, etc. might account for the remaining variability.